All right, section 8-4, we are transitioning from logarithmic expressions. We're now going to solve logarithmic equations, and we'll put in some inequalities. Logarithmic. All right, so it'll look something like this. It'll say solve, because it's now an equation, and you'll have log base, and in this case 9, of x equals 3/2. And our job is to solve for x. I'm going to suggest writing this in exponential form. So 9 to the 3/2 power equals x. So 3/2 power just means 9 to the third, and then to the 1/2, or the square root, equals x. Or it could be 9 to the 1/2 to the third. I actually think I'm going to do this one instead because I can do 9 to the 1/2 in my head. I cannot do 9 to the third in my head very well. So 9 to the 1/2 is 3. So now we have 3 to the third. So that's 27. So x equals 27. Let's do another one just for kicks. How about log base 16 of x equals 5/2? Again, rewrite it. So 16, 5/2 equals x. And I like it as 16 to the 1/2 to the 5th. So 4 to the 5th is equal to x. And so I got to think about this. 4 to the 5th is a really big number. 1024. All right. So that's if you have a log on one side of the equation. What if you have a log on both sides? So we need to talk about the property of equality for logarithms. So equality of logarithms. And this will probably seem like of course it's this way, kind of an idea, but of course being in mathematics, we've got to make sure that we state our properties. So if you have a log, let's say base b of x, that is going to be equal to a log, or if it will be equal to a log with the same base of y under one circumstance. So if that's true, then x has to equal y. Profound, isn't it? You would have never come up with that on your own, I'm sure. Okay, so knowing that, let's try and solve something here. Let's do log base 4 of x squared equals log base 4 of negative 6x minus 8. So the bases are the same, they're both 4, so we have to set these guys equal to each other. All right, so we have a quadratic term and a linear term. That tells us we need to move everything to one side, set the whole polynomial equal to 0. Because we want to try factoring first before we get into any other crazy methods. So factors of 8 that add to equal 6, oh, that's an easy one. X plus 4, x plus 2 equals 0. So x equals negative 4 or x equals negative 2. Okay. So then we have to make sure that it works. Maybe one of these we'll have to toss out. So here we go. If we have x equal to negative 4, let's check it. Log base 4 of negative 4 squared. So that's log base 4 of 16. And we want to see if that's equal to log base 4 of, that'll be negative 2. So that's a 12 minus 8. 12 minus 8 is 4. Okay, so does that work? Does that check? shoot, that's not a 12. What am I doing? Mrs. Carty, you need to work on your arithmetic. Negative 4 times 6 is not 12. It's 24. Minus 8 is 16. Okay, this one works. Phew. Okay, so this one is a yes. Let's try the negative 2. Log base 4 of negative 2 squared. And we'll see if that's equal to log base 4 of, there's my 12, minus 8. So that's a 4. I should put a little question mark there. A little question mark there. So this is log base 4 of 4 equals log base 4 of 4. So we have 2 solutions for this one. All right, that's not so bad, is it? All right, there's some geometry for you. You remember those days? It was not long ago. It was like a year ago. Okay, here we go. Let's look at inequalities. All right, so we're going to solve the inequality. Log base 4 of x greater than or equal to 3. So let's rewrite this in exponential form. 4 to the third must be, pardon me, not 4 to the third. X must be greater than or equal to 4 to the third. Right, because this would be our power, if you will. All right, 4 to the third, so x is greater than or equal to 64. Alrighty, let's try another one. Log base 2 of x less than 4. Writing it in exponential form, x is less than 2 to the 4th. So x is less than 16. Now, when you get into these less thans, you need to be really careful, because when you're looking at the graph of a log function, the graph of a log function does this. It will never go, your x values, notice, never go past the y-axis. So we actually need to put in a 0 there. Only for the less than. So I'm going to put a little star here. Only for less thans do you need to worry about that. Greater thans, you're just going on forever in a positive direction towards infinity. It's okay. But you've got to be careful with the less thans. All right, let's try one more. Log base 5 of 2x plus 1 less than or equal to log base 5 of x plus 5. So we're kind of combining two things that we've done today. We have the same bases, thus we'll take a look at these guys. And now we'll deal with the solving for x. So here we go. Now we have a less than, right? So we're going to have to pay attention to that in just a second. But let's deal with this one first. In fact, I'm going to scoot it over. Oh, that's funny. I wrote a plus 5. It should be a plus 4. It'll make life look a little bit better in the end. Okay, so 2x plus 1 less than or equal to x plus 4. So we've got x, move the 1 over, less than 3. Alrighty. Now, we know that this guy has to be greater than 0, correct? Our exponent here must be greater than 0, or our x value must be greater than 0, so 2x plus 1 must be greater than 0. You could have taken, no, you need to take the smaller one, sorry, because it's pointing in this direction. Since it's pointing at this guy, you got to take this one. So we solve and we get 2x greater than negative 1, x is greater than negative 1/2. So to do a little sandwich guy, we have a minimum of negative 1/2 for x. We have a maximum of 3. So if x was negative a half, I know you're like, wait a minute, I thought we couldn't have negative x's. You can if you have an expression. This was just x, right? This guy has to be greater than 0. This is what has to be greater than 0 here. This is an expression. So you could have a negative, possibly, that would make this equal to 0. So that's how that works. All right. Okay, I'll see you in Zoom.